Question number 2 of this exercise says that a right triangle whose sides are 3 centimeters and 4 centimeters other than the hypotenuse is made to revolve about its hypotenuse. We have to find the volume and the surface area of the double cone which is formed. We can choose the value of pi as found appropriate, so we can take it either as 3.14 or as 22/7 as it suits us. So to start with, we'll understand how a double cone is formed. So here let's take a triangle ABC, which is right angled at B and has got its two legs, that is BA and BC, with lengths 4 centimeters and 3 centimeters. Now this, when revolved around the hypotenuse AC, forms a double cone. So we have a cone which is at the top and a cone which is at the bottom. They both have got the same diameter and hence the same radius. So dB would be the radius for them. And if I take AD to be the height for the cone which is above as H1 and DC as the height for the cone which is below as H2, we would understand that the total length, that is H to be equal to H1 plus H2, will be nothing but the length of the hypotenuse. So we'll start by finding the value of the hypotenuse AC, which will be equal to under root 4 square plus 3 square, that is 16 plus 9, which equals 25, and so we get the length of the hypotenuse as 5 centimeters. So we can now write in place of H1 plus H2 5 centimeters. The next part that we have to do is to find the common radius for both the cones so that we can find its volume and its surface area. So what we'll do is we'll first find the area of triangle ABC. So we can find it with the formula half into base into height. We can take 3 centimeters as the base and 4 centimeters as the height. So this is the area of triangle ABC. But for the same triangle, when it's revolved, we'll have the triangle like AB-C. And if I take DB dash to be the height, AC becomes the base. So then we can write it as half times DB dash times AC will be equal to 1/2 times 3 times 4. And on calculation, we'll get the value of dB dash to be equal to 2.4 centimeters. So basically what we have found out now is the common radius for both the cones, which will be R equals 2.4 centimeters. Now we can go on to solve the question with the first part, which asks us to find the volume of the double cone. So the volume of the double cone will be the sum of the volume of the cone which is above and the volume of the cone which is below. So we can write it as volume of double cone equals the volume of cone 1, that is above, and the volume of cone 2, which is below. So we write the formulas as 1/3 pi r square H1 plus 1/3 pi r square H2. We can take 1/3 pi r square common and we are left with H1 plus H2. So as we know all of these values, let's substitute them in. We substitute them in with 1/3 times 3.14. R square will be 2.4 the whole square and H1 plus H2 will be 5. So on calculation, we get the answer as 30.14 centimeter cube, and that is the volume of the double cone which is formed by revolving the right angle triangle ABC about its hypotenuse. Now we'll be going on to the next part of the question, wherein they have asked us to find the surface area of the double cone. So the surface area of the double cone will be equal to the surface area of cone 1 and the surface area of cone 2. So we can write it like this. Now we'll substitute the formulas for them, and that will be pi r L1 plus pi r L2, where L1 and L2 are the slant heights of the cones respectively. So this is cone 1, this is cone 2. So as we can see, this part forms the slant height of cone 1 and this part forms the slant height of cone 2. That is 4 centimeters and 3 centimeters respectively. So taking pi r common, we are left with L1 plus L2. So let's substitute that as 3.14 times 2.4 times L1 plus L2, which will be 4 plus 3, and that will be 7 on addition. So 3.14 times 2.4 times 7 will give us the answer as 52.75 centimeters square, and this is the total curved surface area of the double cones so formed by revolving the right angle triangle about its hypotenuse. And this is how we solve this question.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.